All right, we're going to solve using duality, which means the first thing we have to do is turn this min into a max. So let's do that. So again, let's create a matrix. This is off to a side matrix. It has no other purpose except to turn it into a max problem. The first rows above the horizontal line there are your functional constraints. So in this case, 1, 2, 10, squishy, 1, 1, 8, 2, 1, 12, and your last row is your objective function, 3, 2, and you'll see the book put a 0 here. It doesn't matter what you put in that bottom right. We're going to transpose it. That's what that capital T means. So every row becomes a column. Every column becomes a row. So instead of the first row, 1, 2, 10, we now have the first column, 1, 2, 10. Second row, 1, 1, 8 becomes the second column, 1, 1, 8. And third column, 2, 1, 12. And then 3, 2, 0. I'll make it more oblong because it got flipped. So this turns into a maximization problem. Again, switch to z's, x's, and less than or equal to's. Look at the last row, 10, 8, 12. That becomes 10x sub 1 plus 8x sub 2 plus 12x sub 3. Subject to your first functional constraint comes from the first row, 1, 1, 2, 3. So x of 1 plus x of 2 plus x of 3 less than or equal to 3. Next one, 2, 1, 1, 2 becomes 2x of 1 plus x of 2 plus x of 3 less than or equal to 2. And then you have your non-negative constraints, always greater than or equal to 0. So what we have in blue there is our dual max problem. We're going to solve it as a maximization problem, which is what we did in the last couple of sections. However, to get the answer for a standard min, you just read your tableau differently. So since you are totally familiar with solving a standard max, because you've had like 5 examples, a lot of pauses about to happen here. So turn that max into initial simplex tableau. We'll make sure that's okay. And then we'll get pivoting. All right. All right, hopefully you realized I made a mistake. I lost my 2 right here, which is crucial because that one turns out to be the pivotal one. Oh my gosh, I got a message, which means my phone's not on silent. Let me turn that off. All right, let me look on my Facebook. All right, I'm good. I think I'm good. There's nothing on Facebook right now. All right, so please fix that. Again, the first functional constraint should be x of 1 plus x of 2 plus 2x of 3 less than or equal to 3. Sorry about that. I am sure you were panicking, maybe at the disco. So as I said, that 2 becomes the pivot element. You should have pivoted so many times by now. You know what's coming up next. In fact, I'm going to jump right to the final tableau. I will tell you that there's 2 more pivots coming. So again, this part is no different than what we did for 2 sections now. So keep pivoting, and I'll see you in a couple seconds. Well, not really, because I'm at home, and maybe you're at home or at the airport or somewhere. Toy store. Give me something nice. Thanks. All right, I have no idea what I said previously. I think I said there was only 2 pivots. I lied. There were 3 pivots total. Oh, I forgot to write this one up. Oh no, I'll do it over here. I'm not editing this out. You're gonna have to wait. I feel so bad. And I'm over it. All right, I feel better now. Okay, so we did all of our pivots. That's great. There's no more negatives in the objective function row, so we're done. The difference is how you read the answer. So our original problem was a standard min. So we do not read across. As it turns out, we actually read down underneath the slack variables. Notice in the original min, we had two y's, y1, y2, for example. And in the standard max, we have two slack variables, s1, s2. So to find the values for y1, y2, you actually read below the slack variables into the objective function. So below s1 is the number 4 in the objective function row, which means that the original y1 is 4. And below s2 in the objective function row happens to also be another 4. So the original y2 is also 4. And then the z value is the same as the x value, as the w value. For that one you read across. So if z is 20, that means that w from the min problem is also 20. So in this case, ordered pair that minimizes the objective function is y1 is 4, y sub 2 is 4, and the minimum value for w is 20.